Good morning, students. I am Dr. N. Sai Kumari from RMK College of Engineering and Technology. And today we are going to see a very important topic, chromogenic materials, which comes in Unit 4. Yes. Now, what do you mean by chromogenic materials? Actually, chromo means color. There are some materials which are able to change their color with respect to the changes in the environmental conditions, and they are known as chromogenic materials. The chromogenic materials are in general which change their properties with respect to their external stimuli. Actually, how do these chromogenic materials exhibit a property which is known as chromism? This may be due to the change in the equilibrium of electrons or the cleavage of the bond, that is, the chemical bond undergoes a breakage when they have been subjected to external stimuli. And that is this external stimuli which brings out the change in the equilibrium position of the atoms. Otherwise, when there is a cleavage of the chemical bonds, actually they bring out or they modify the optical properties of the given materials. Actually, the electrons, which are namely pi and d electrons, particularly which are meant for the color, they undergo the change in their positions because of the external stimuli. Once the external stimuli ceases, they come back to their original position, and actually they restore their that is energy density back. And these materials, chromogenic materials, are used in various fields. Based on the various environmental conditions to which materials have been subjected to, the chromogenic materials are classified into different types. The first one is photochromic, and here the change is color with a change of light. Thermochromic, here they change the color with a change in the temperature. Electrochromic, they undergo change in the color with respect to the applied electric field. Mechanochromic, they change the color with respect to the mechanical stimulus, that is the extent of the stress or strain which is applied. Piezochromic, the change in the color with respect to the application of the pressure. Chemochromic, here they change the color due to the chemical changes in the environment. Halochromic, they change the color with respect to the pH changes in the environment. Solvatochromic, they change the color with respect to the change in the solvent. Now we go to the photochromic materials. The photochromic materials, they change the color when the intensity of the incoming light changes. And they can be used for designing optical switches, optical data storage devices, and energy conserving coatings, and eye glasses, and privacy shields, etc. Photochromic materials and systems have several important uses. They have other uses on the rate of the transformations they undergo with respect to their optical properties. Next one is thermochromic materials. These materials respond to a variation in environmental temperature by changing their color. These type of materials are used in designing some of the devices like our appliances like thermometers and clothing, paint, and containers, especially which are used for packaging drinks, toys, battery indicators, plastic products, various plastic products, especially in producing a t-shirt, thermochromic t-shirt, etc. Now, heterochromic materials. The heterochemical materials are characterized with respect to their optical change on the application of electric field. These materials, especially the heterochromism, is probably more versatile with the chromogenic technologies because it is easiest to control, manipulate, and can be used in various combinations with respect to the various type of stimuli, otherwise stress or temperature. Heterochromic materials are able to vary their color and transparency to solar radiation in a reversible manner, and they are highly have a command in a big market for dynamic anti-glare mirrors production, and also to detect glare and automatically compensate it itself, especially for night time driving in a safe manner. Now, mechanochromic materials. These are the materials that show change in the color when a mechanical stimulus like a stress is applied. These materials are currently studied intensely because of their critical use in the stress detection, particularly in situ failure monitoring due to fracture, corrosion, fatigue, or creep. And the important group of materials with a huge range of wider applications such as data storage and sensors, memory chips, security links, and certain light devices due to its very simple operation and rapid response. Now, chemochromic materials. The chemochromic materials respond to the chemical changes in the environment by changing their color. Chemochromic materials are the materials which react with the different chemicals and exhibit a change in their color and in some cases in their reflection properties, transmission properties, etc. And they are used to show the ripening of the fruit as the chemical reacts with the gases released by the fruit when it ripens. The major application of chemochromic materials we can find in the detection of gas, toxic gases, and especially in rocket engines and sites, industrial sites, even domestic gas explosions that can be even avoided with this particular type of materials. Halochromic materials. They can be considered a subgroup of chemochromic materials actually. They change a color with respect to the pH changes in the environment. Halochromic materials are commonly used materials that change their color as a result of changing acidity. And they are well suited for the use in environments where pH changes occur quite often and are the places where the changes in the pH are extreme. Halochromic substances detect alterations in the acidity of the substances like detection of corrosion in metals, etc. Salvatochromic materials, these are the materials which display the phenomena, the salvatochromism, because of some chemical substances that are sensitive to a particular solvent. The salvatochromic effect is the way the spectrum of a substance that is in the form of a solute varies when the substance is dissolved in different types of solvents. These materials are actually used to predict the color of the solution. Now, biochromic materials. Biochromic materials were developed to detect, otherwise to find the presence of pathogens with a color shift. Potential applications of biometric materials include colorimetric detection of microorganisms or pathogens against food poisoning. Researchers developed a green and sustainable, some scientists, they developed a sustainable smart biochromic and therapeutic bandage using the natural vegetable like red cabbage extract into alginate. They have been encapsulated into alginate nanoparticles. Now, what are the common applications of these chromogenic materials? They are used in digital displays, food packaging layers, and they are able to manage smartly the solar energy variations, They are energy effective windows. They're used in the production of energy effective windows for buildings, aircraft, automobiles, and optoelectronic and medical industries. And they also act as very good sensors. They are used in supercapacitors, which act as energy storage devices. Thank, thank you, students.